What it do? It's your boy Codehova with Fly Combinator. We're pimping Swift, and we're going to talk about the mutability of reference type. So if we go back to the struct we worked on, the dope boy struct, if you remember the function sell grams, we're going to give it a parameter of grams, and we're going to check that gram on if the dope boy has more than those grams on hand. All right. So if he's able to do this sale, we're going to subtract the number of grams he's going to sell from the grams he has on his person. All right. So because of that, we dealt with the mutating keyword added prepended to the function. So when we're dealing with structs are value types. So when we add this new this keyword of mutating to this function, what we're doing is when we do grams on hand minus equals grams, what we're doing in this equation, this subtraction equation, is we're pretty much updating the variable of grams on hand on an instance of dope boy with a new value. Okay, so that's the difference. That's why we had to add this mutating keyword to this function, because this subtraction equation is going to update the value on grams on hand for the instance of dope boy. So, excuse me. So if we go back to the class of a hustler, I have brought over this that same function over. But with classes, we don't need to add the mutating keyword because we're doing this grams on hand subtraction equation. All right. Because classes, the reference types, they're mutable by nature. All right. So we have already declared that grams on hand, this stored property on an instance of hustler, can be changed. So that's why there's no mutating, there's no keyword of mutating prepended to our function. So if we say that Codehova, this hustler, is going to have 50 grams on hand, and let's say Codehova is going to make a sale for 25 grams, and we run it, boom. I have successfully sold 25 grams, and now I only have 25 grams left. Let's double check. Codehova, grams on hand. We run that, and it's true. 50 minus 25 is 25, so he has 25 grams on hand left, and that's because we have a variable on an instance of hustler, and when we run this equation here, it's just going to update this variable with the correct value. It's going to be able to do 50 minus 25 and update grams on hand to 25 instead of creating a brand new value and storing it in that variable. So that's the difference. That's the difference of how reference types are mutable by nature, but that doesn't mean that, let's say we have John Doe. Okay, John Doe is a hustler too, and his name is John Doe, and he has 50 grams as well. That doesn't mean that we could say John Doe is going to be equal to hustler Jane Doe with 25. Because if we run this, it's running with an error. It knows something's wrong. But anyways, before the error pops out, so this is a constant. So we're saying that this value can never be changed. All right. So yeah, cannot assign value John Doe because John Doe is a it's a constant. So we already have declared that this is a constant. It can't be changed. What this does mean, though, when we do the sale from this function of selling grams, we are able to update the variables within a instance. Now this is not going to work because we have made sure that John Doe is going to be of one type of hustler and it's never going to change. But if we were able to change this to a var, we're going to be good, because if we now say John Doe dot name, it's going to be a Jane, because we did say that this is something that could be changed. All right, so that's just the mutability of reference types. there's a subtle difference from structs and classes. It's your boy Codehova, Fly Combinator. If you have any questions, leave them in the comments below. But let's continue on. Learning Swift, pimping Swift, and getting that bag. You dig?